Hello. So I'm going to be doing a presentation on in Tsurugi, and I'm going to be using fuzzy hashing technique of a tool which is called ssdeep, which helps us to do analysis on documents and files to see if any changes have been done to our files. It just utilizes hashing algorithm. Hashing algorithms, these are important when it comes to checking integrity of documents. If anything or any change has been done on a certain document, we can be able to see it because the hash value will change drastically. So that can be able to help us where maybe when we are analyzing evidence, the initial evidence that was collected, we can be able to compare that hash value with the evidence that will be submitted in court to see if any changes were done on that document or that set of evidence. And this is quite important in our forensic analysis. And in some cases, when companies are analyzing their documents and maybe someone is done intellectual property theft, and we can be able to tell that when we analyze the documents to see any changes which were done to our documents and be able to pick up any form of theft. So I'm going to be doing this using that application that we'll find in our three liners in environment, and it's under hashing. It's called the fuzzy hash, and fuzzy hash ssdeep. So this is how it works, and these are the basic commands that you can run. But for me to be able to do this, I will need to navigate to a folder that I've created. This is the folder, and this folder is got quite a number of documents. And initially, I want to start with these two documents. These two documents, document one and document two. These documents are different, but we want to see if they are how we can tell if they are different using hashing in a hashing algorithm. So I'm going to navigate to this folder, and it's on my desktop, and the folder is called fuzzy. Right. So I'm in my folder now. So let me just check if everything is there. Yes, they are there. Two of my documents, PPT and the document the one and number two. So since my documents are now there, so let me first use the commonly used hashing algorithm, which is called MD5 sum. So MD5 sum, if I run it here, it should be able to tell me if these documents are in a way similar. So I've run this and it has generated these two algorithms, these two strings, which are telling me that these documents are definitely different because the hash values are different. But maybe to analyze this better, I need to store this output as a txt file. So I'll just call it hash.txt so that I can be able to analyze it later. So in my previous folder, I can see it's now there as a hash.txt file, and if I open it, I will be able to see these figures, and I can tell that they are the hash values, they are different. But we need to do more. Just we don't want to just see if these values are different. We need to do more to see if they are even in any way similar. We can want to do similarity analysis because sometimes the documents may have changed a little, and the hash values will be different. But we need to check if they are in a way similar or related. So I'll just copy this document uh, and paste it in the same folder. So it's the same document, nothing has changed. And I'm just going to run the same MD5 uh, MD, MD5. And now instead of creating an additional file, I'll just have to append this output into the same hash txt that I've created already. Right. So I've run it and I want to check now if there are changes to my file. So as you can see, the initial one that we did was this one and two, and these documents were compared. But now I've introduced the third document, which is the copy. As you can see from this, the hash values are still the same. The documents are similar. It's just a copy. What has changed is only the name, but the documents are same. So we can be able to tell that it's the same document, right? So now let's go on to that document, that copy to open it. Want to change one thing, just one item. For example, on this one, I want to change the name of this person who was given a contract. So instead of Pinias, I'll write Tom, and I'll save the document. And I've saved it. Let's see if it changes if it affects our hash value. So I'm going to run it again and append the outcome into that document. and open it. All right, these are the last documents. As you can see, the hash value has changed drastically. They are no longer the same. So this can help us to see someone has altered our document. However, if they are related, how can we be able to tell? Because this is just telling us the documents are different, even though we actually know only one item was changed in our document. We need that insight to be able to tell if the documents are related in a way. So I'm going to be doing the ssdeep using the ssdeep hash. So I'll run the ssdeep and want to analyze everything in this folder, and the output I want to append it into to that to hash.txt. All right, let's open the oh, it's a different. Okay, maybe because of the spelling error, I've created another document. As you can see from the hash values, that why when we do ssdeep analysis, it will give us the block size, the hash, and the file name. So the hash in question and the file name. So as we can see from this output, the document still has got the same number of blocks. So the block size is still the same. However, the hash values are different. They have changed because we have altered something on that original document. So we can be able to tell that someone has altered our document, and this is very important as a presentation in the court of law. So we would like to do more, and we want to do a similarity analysis, and this we can do it using for us to be able to do it. Let's first convert our ssdeep not into the text file, but maybe let's just create an ssd file, fuzzy, say fuzzy dot ssd. Right. So I've created our fuzzy dot ssd file. Then this fuzzy dot ssd file, we want to we'll do a similarity analysis to see if there are any items that are similar in this document. So fuzzy and ssd, then uh, we run the code like this. So let's see what output I'll get in that fuzzy document. All right. So where's the output? All right. This is just showing us the same information that we have been getting all along. But what we want to do is to do the similarity analysis. Sorry, it was still going on. Interesting. This is deep and okay. So this is the code that we want to run, so that we can be able to tell if there are similarities in our document. So as you can see here, the output is helping us to the output is doing those comparisons. So the document one, the copy, it matches itself 100%. So it's the output is in percentages. Same as the document one, which was the original one, it matches itself 100%. And the PowerPoint matches itself 100%. And these are the SSD files. Okay, those are the ones which have changed. But we can also be able to, because I just altered one thing, that's why they appear to be the same. However, if there is significant changes on our document, we can be able to, if there are significant changes on our document, we can be able to pick it up on this item. So what I'm going to do is I'll go back to that folder and alter the document, this one, the copied one, and change it quite significantly. So open it. All right. So I'm going to change maybe at the bottom just to alter everything else, maybe starting here from salary, and I'll clear everything and save it. Yes, save. All right, so I'll run the same code once again to see if the changes can now be picked up. And from here, I'll just run the same code. And as you can see, The same comparisons are being done. The copied document, when you compare it to that initial the this document one copy, it matches this copy 43%. This is now telling us something has happened to our document. It has been altered, and the system is now picking up. We're now comparing the original document to the copy, so we can see that there are some changes that have happened in our document. However, for comparing document one to document one, is still the same, and the PowerPoint, everything else remains the same. But this one, this aspect of the original one to to the copy one, things have changed. So you can be able to tell the documents are similar, but 43% of the items have been changed. And this is quite important in our analysis. And you can be able to tell if anything has happened to our document. Additionally, we can do a different diff analysis. Just to, if you run a code, we say diff and put the document, maybe the one doc x, uh, doc x, and number one dot doc x, uh, doc x, the copy one, and see if they are different. Oh, sorry, syntax not correct. Um, I can do it. I can do an easier way. For example, this one. Let me just rename it. Let me just rename this into 3. That's the ones that we have altered. So to see if 3 is different to from 1. So let's just do the same. Say if 1 dot docx and 3 dot docx. All right. So the output is just actually telling us that at binary level, these documents they differ. But with this information and the one that we have gathered, we can be able to tell that the documents are similar. However, they differ, and in areas that they differ, they are quite important in our analysis. Thank you.